Okay, y'all. I apologize for the pivot. I had to be out. You know, freaking baby germs again. But I'm just pivoting to make sure that I can help both classes. So first block, we sort of got um, to a point where we were looking at the second triangle existing. Um, and then we were going through that. So what I'm going to do is just go through your setup again, and then we're going to just kind of quickly go through solving the different things for both classes here. Okay, so we're going to go to page 17. um, I believe it is in your packet. If it's not page 17, it might be um, 16 or something like that. It just depends, but it says this at the top. Okay, I can't remember if the page number matches up or not, so I apologize. All right, so we're gonna run through the no triangle. We'll run through one triangle, and then we'll run through two triangles existing. All right, so quickly remember all of your pictures we're gonna draw the same way. So we're gonna have the angle that we know in the corner. Now we're not drawing this to scale. So I know 136 degrees is not this small. Okay. But what I want to do is get you to understand that visual from the video about the second triangle. Okay. So this is C. So this is C. That means this is B. This is B. And so we are, um, you know, stating the number of possible triangles that can be formed. If a triangle is possible, find the measures for all the sides and all the angles. Okay. Um, all right. So we have this, and so we're gonna just start solving, right? So remember we talked about yesterday which angle we have to go with first. So in this case, we have to solve for angle C first. So I'm gonna set up the law of sines. Angle C. The reason why we're doing that is because we have its opposite side. Okay. Now remember your process for solving: multiply to get the variable by itself. Okay, and our calculator, we are literally going to type in this entire thing, and then do the inverse sign of it, because remember we got to get capital C by itself. So we're literally going to be doing the inverse sign of this entire thing, because remember, if we just do the fraction, we'll get a decimal, and then we'll have to do the inverse sign of that decimal. So either way, it'll work. All right, so if I go alpha y equals 25 sine of 136 over 8, right, we get this 2.2 as the decimal, and then we're going to have to do the inverse sign of that decimal. But I can also do inverse sign of the whole fraction as a whole, right, and just cut out the middleman and just do it all at once, right? So that way I stay exact here. But either way, once I get to that step, look at the error that we get. So remember, if we get an error, we say no triangle exists, because at this point, I couldn't even solve for the first angle to begin with. So we have no triangle at all that exists. Okay. Now we're going to skip, and we're going to do one that has one triangle. So we're going to draw a picture. Remember I said we're going to be very generic here. We're going to draw a picture the same way every time. So we're going to mimic the video. The only time we have to do this is if I give you one angle only. So 96 degrees is the only angle you know. The opposite side is 26 because that's lowercase b. The other side goes next to it. Remember, the bottom stays free and open because that's the ambiguous part of it. And so then we will label this as capital A because we had lowercase a, which means that's capital C. That's lowercase c. So from here, we're going to just start solving. Okay. What we are looking for is we are looking for angle A, angle C, and lowercase c. Up here, we were looking for C, capital B, and lowercase b. It's just that we ran into an issue that the triangle doesn't exist at all. So basically what that meant was the opposite side is too short to even make a triangle exist. So here, we're going to try the same thing. We're going to start by just solving for what we absolutely know we can solve for, which is angle A. So we're going to set up, and solve. So literally the steps are going to be the same every time here for this first step. It is just solve for that first angle. So we multiply there. We get 25 sine of 96 over 26 equals the sine of A. Right? We type this in, we'll get a decimal, and then we'll have to do the inverse. So I'm just going to cut out the middleman. Right? I'm solving in my head, so I know what my next steps are going to look like. So I'm just sort of cutting out the middleman and just going ahead and going to that next step. So now, get out of this. Okay, so we're going to do second sine of this fraction. We get an answer. We do not get an error. So this is 72.99. So here, y'all, by default, we're going to have to just say 73 because it's 0.99. So we're going to say 73 degrees, okay? So angle A comes out to something, 73 degrees. So now we have a value, which means we know at least one triangle that does exist. So now, which again, our picture doesn't actually get drawn to scale, we're going to push the 26 in to make a second triangle, right? That's the whole idea, is that that second triangle could exist because this opposite side could swing inside to make another triangle on the left here. So, if you remember from yesterday, we talked about the isosceles triangle concept. When you push this opposite side in to make the second triangle, you create an isosceles triangle on the right. And isosceles triangles have rules that state, or properties that state that these opposite sides here are equal or congruent, meaning these angles here are congruent. So whatever angle you get in this corner, you can push to this corner. And then it allows us to find the angle inside of here in our second triangle by doing 180 minus whatever this angle is here, okay? Whatever we found, okay? Because remember, we talked about if you have a straight line, it's 180 degrees. So if I cut it with that line, I just know that those two angles add up to 180 degrees, okay? So going back to our problem, okay? So we have 73 degrees. We have an isosceles triangle because we're doing an imaginary push of side 26. So we're gonna now swing this over. But to get our second triangle going, we're gonna have to do 180 minus 73. So in our second triangle, I'm gonna go ahead and draw it. Right, you know, I'm not finding anything else. I am setting up the second triangle right away. Okay, so our second triangle roughly looks like this. We still got the 96. Remember, in that second triangle, all the other stuff that I gave you to begin with still exists in that second triangle. It's just that now we have new values for those three things. So we were looking for A, C, and C. Well, in the second triangle, we're still looking for A, C, and lowercase c. It's just in the second triangle, okay? So in our second triangle, our A is going to be 180 minus the other A that we got. So for those that sometimes get stuck, your second triangle always starts by doing 180 minus the original angle that you found from the first triangle. And so then our new angle A would be 107 degrees. All right, this comes out to 107. But this is where you use your common sense. You would go, hold up. We are already bigger than 180 degrees here. So there is no way the second triangle exists. Okay, so the second triangle cannot exist, which means you would stop and you would say there's only one triangle. Okay, so second triangle can't exist now, so we have one triangle. And that's what you would say. Okay, now what we're going to do is we're going to finish though by finding the stuff from the first triangle that we can find. So we know that one triangle exists. So that's all we can say here, is that one triangle exists. And so what we're going to do now is we're going to find missing information for that first triangle. So we found the 73. Now we can just go back to finishing this up. So now that I know angle A and B, I'm going to find angle C at the top. Because it's a triangle, 180 minus those two angles means we have 11 degrees up top. Okay, now that I know 11 degrees on top, I can now find lowercase c on the bottom. So I'm going to set up a law of sines using what I already know. So 96 and 26, you always start with what was given originally because that's the most exact you can be. Lowercase c on top and then angle c at the bottom. And then we're just going to solve. So we're going to multiply both sides by the sine of 11. Okay, in our calculator, we're going to do alpha y equals here, 26 on top times the sine of 11, because we multiply both sides by the sine of 11. On the bottom is the sine of 96. And so that side C is going to equal 4.98. So technically, we're just going to have to round that to 5. Okay, and so this comes out to 5, and we're done with that. Okay, now we're going to do an example that has two triangles. Okay, I have 3 minutes, y'all, because the videos are limited to 15 minutes at a time. But I figure if you can watch a 15-minute video, then hopefully you'll be good. It'll keep your attention long enough. Okay, so 54 degrees for angle A. This is the second problem here on this page. 54 degrees here, so that means 26 is there, 29 is over here. Okay, so then by default, this is side C, B, B. So we are looking for angle C, angle B, and side B. So we're going to do our law of sines. So we're going to say sine of 54 over 26 equals, we're looking for angle C. Put that there. I'm going to multiply. So I may not show all the steps just for the sake of time, right? And then I'm going to get sine of capital C equals whatever this is. And then I'm going to do the inverse of that. Okay. Now remember, if I do it quickly here without there, I do 29 sine of 54 over 26. I'm going to get a decimal, and then I'm going to type in on that decimal, right, I'm going to do the inverse. So capital C, when I do the inverse, will be this, second sine of the entire answer. Remember, use the whole decimal, and we get 64.5 degrees. Okay, so that's our angle here, 64.5. And so now we have that angle. And so we're going to see if that second triangle exists. So we're going to draw the second triangle. And we have 54, 26, 29. And so we are going to look for our new side, angle C. And we're going to see if it exists. So if I do 180 minus the other angle we just found, 64.5, I get 115.5. 115.5 degrees. So in our second triangle, angle C has to be 115.5. Well, if I look, 115.5 plus 54 is only 169.5, which means I do have enough for the second triangle to exist, meaning the top angle is 10.5 degrees, which means we do have a second triangle. Okay, so here, 2 triangles exist. And then all you guys have to do now is finish. Okay, all right.